Okay, so these questions do come up quite a lot. I've very rarely seen them on paper 1. They're generally going to be on paper 2. So I have got instructions how to use your calculator to do this. And if you've got your calculator, it should be a dream. You're just literally checking numbers in. What is binomial distribution? Well, binomial distribution kind of takes into effect if you've got a fixed number of trials of something happening. Okay, so the kind of question is going to be that an event happens large times. Okay, with these events, they're looking at a success or a failure. Okay, so there's only 2 options. So it's not like rolling a dice where there's 6 options. We've either got rolling a 6 or not rolling a 6. Okay, so you've always got to do it into a yes or a no situation, positive or negative. The probability of success is assigned the letter P. Okay, and it's the same no matter how many times you do the event. Okay, so the situation that you're going to come up with is you're going to look at the question and hopefully see that you've got something happening or something not happening, and it's happening repetitively. So that's when you're going to look at these kinds of questions. You've got, this is often how something is shown to you. So you may have it's got a big X with a B showing its binomial distribution. The N is the number of trials that you've got, and the P is that probability of success. So it could be summarized in a question, or it could just be words that you have to draw out of that. Okay. You have this in your formula booklets. I'm assuming it's on the probability page. Can you see your probability? I can't really see. So it's that sounds really healthy, darling. Binomial distribution, yes. So it's down near the bottom. It says 5.8. Okay, the first row, 5.8. So, what do these mean? Well, we're familiar with the NCR. Yes, that's the same as binomial expansion that we've been looking at. This is the probability of success to the power R. 1 minus the probability of success, so whatever value this was, we're going to do 1 minus it. So the probability of N minus R. Okay? And that makes sense. These are the successes. These would be the failures, or not success. As a reminder, if it was on paper 1, you could be using this formula to help you establish the value of NCR, because it's probably going to be too big for a Pascal's triangle situation. Okay? Do you remember what these mean, the exclamation marks? Yeah, so it just goes down in even more stuff. All right, so a fair coin is tossed 10 times. Find the probability that 6 heads occur. Firstly, do we recognise that that's binomial distribution? Okay, we've got a set number of trials. We've got a head we're talking about. Okay, so obviously there's a head or a tail. There's a success or a failure. So we would write here the probability that X is equal to what? What do they want to do? They want to know that 6 heads occur. You don't want? You don't have your bit of paper? I don't know. I gave it to you yesterday. Alright, okay, so we're talking about 6 heads. Okay, so we've got 6, so we want to find out when it's 6. So that's going to be equal to, so what will our N be? 10. Yeah, so N will be your number of trials, so that's going to be 10. So we need to find 10, C, and what do we want to find? How many successes? 6. So far so good?
Yeah.
What's the probability of getting ahead? Half. Or 0.5, whichever you want. And that's going to be to the power 6. And then what's the probability of failure? Half. So in this case they are the same. and that's going to be to the power of,
4.
careful,
4?
4. Why 4?
Because 6 minus 10.
Trivia.
Or yeah, that way.
Say me. I shouldn't say that because it will tickle. But we know it.
You still get a 4.
Alright, should we do one without the calc just in case they come up?
So you just leave it like that?
No, so we have to now work out what this is. Okay, so let's use this formula here to work out this 10/6. Okay, just in case they come up. It doesn't hurt to go through these things. So we need to find 10 factorial over 6 factorial brackets 4 factorial. Now, do you remember the sneaky thing that I was telling you when doing these?
So, because you have a 6, you can cancel out.
You can often cancel them out, yes.
I think it just maps it.
So this is obviously 10 times 9 times 8 times 7 times 6 times 5, blah, 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 blah. And then this one is going to be 6 times 5 times blah, blah, blah. And then this is 4 times 3 times 2, blah, blah, blah. Okay? So my blah, 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 blahs, I'm going to get rid of all of these ones, and then from there down.
Wait, why do 2 1/2 spelled like that?
Because this is success and this is failure. It just so happens that in this case they're both 1/2.
Like a 50-50 challenge.
Because it's a coin.
It's not always going to be like that. So obviously if one was 0.2, the other would be 0. Right, we now need to try and get rid of my 4 times 3 times 2. I can see that if I get rid of my 4 here, that would then become a 2. So I'm just looking for shortcuts here. And my 3 I can get rid of, and then this will become a 3. And then I can get rid of my 2 because I can cross out that 2 again. Or you can cross out anything that's even.
Oh. Could you not do 2?
You could make that as 5 as well. Yeah. Okay, so I'm left with now 10 multiplied by 3 multiplied by 7 over 1. Okay, because I've crossed everything out on the bottom. Okay, so that's obviously 210. So as I say, I wanted to do one of these just as a recap, just in case they did come up. Pardon?
She's actually in here.
You didn't get that?
Yeah, where did you put where did the 2?
So I crossed this 2 out,
Oh.
but you could have made that one a 5. You end up with the same answer. You would just have 5 times 3 times 2
Times 7.
times 7.
Oh my god, no.
Alright, so you're just trying to find shortcuts and trying to cross stuff out.
And that equals 2 3.
Because 10 times 3 is 30 and 3 times 7. 30 times 7.
21. Now that floats here, but
So that
the
means
2 went into the 8.
Yeah, twice. Yeah.
So
Not 4 plus 4.
the 2 went into, so that was, okay, yeah.
Yeah? Yeah, we all good?
Yeah.
Alright, so this value here is 210. We got to work out what this is. Ooh, that's not easy, is it? So we're going to have 1 over 2 to the power 6. So what's 2 to the power 6?
2 to the power of 6. Yeah, 2 for 2.
2, 4, 8,
16, 32, 64.
okay, 64. And then 1/2 to the power 4. So we've now got 1 over what's 2 to the power 4?
2, 4, 8.
Remember, this is over a 1. Let's do some cancelling.
Let's cancel all the 6s.
When I say cancel, we've got to cross out numbers. Work stuff out.
I feel like 64 goes into 210.
Say what? You think 64 goes into 210?
Something's telling me that.
No, I don't think so.
It has to.
10.
Well, let's halve
Because 4.
Well, let's halve this, make 32, and this can be 105. How about that?
Yeah.
Is that a good start? I don't know if anything else goes into it.
Yeah. 2.
No, it's
No, 2 doesn't
it's
have
odd.
105, darling.
Oh.
1.
3. 3.
3 goes into 32.
No. Maybe that's it. What's 30? 4? But 4 doesn't go into 105.
No. Why you didn't put the 2 in the 16?
Well, we're going to have to. What's 32 times 16? This wasn't a very good idea to do this by hand, was it?
12.
6 times 2 is 12, 3, 6 are 18, 19, 0, 2, 3, 2, 11, 4, 5. 5, 12. Okay, so we've got 105 over 512.
Wait, where's the 5?
I carried by 1.
Okay.
Let's do 5. Have we done that right? Have I done that right? I might have made a mistake.
Wow.
Should we do it on the calculator, please?
Maybe, just in case, yeah. Doesn't hurt to double check.
How do we do this?
Okay, let me pause it while we tell the time. Okay. Okay, another question. Probability of a particular page on a maths book contains a misprint is 0.2. Find the probability that 12 pages in the book, that of 12 pages in the book, 4 of them contain a misprint. Okay, so A. We're trying to find the probability that X is equal to 4. Yes, you happy with that?
Yeah.
Our value of N in this case is 12, so we've got 12
C.
and 4. Oh, yes. So we can either write it as 12C4 or just 12-4. Same meter for Brady, yeah? What's the probability of success here? Well, success in our case is having a misprint, yes? So what's the probability of that? So that's going to be 0.2 to the power of?
2.
Careful.
4.
4, yes? And then our failure would be 0.8 to the power of?
2. 3.
Stop shouting out numbers at me.
What's
Think about it, Mally.
I knew that.
Okay, let's just do this one straight on the calc, because that was too painful we're doing all that before. So go to menu, combination, no, probability, combination,
Oh, I always
and write 12, 4.
I'm glad not this tattoo. Who's my money get?
So what's that value?
495. 2. Wait, hold on. You have to.
But you're not being recorded talking rubbish. Could you, someone have a go at this?
My calculator's there. Where is it?
Oh,
It's good. Where you have the 495?
Don't you tell me that's what 12-4 was.
Yeah,
okay.
I'll just put it all in.
Is that confusing because it makes a bit?
Oh my goodness.
0.13.
1, 3?
Yeah.
So have you rounded it?
1328.
Remember what did we round to?
133.
Okay, so that's another reminder to everyone, round into 3 6 big or the exact number.
Wow.
Okay? That's it. Yeah?
That's it.
Now, part B is slightly different because you have to think about this. It says fewer than 2 of them contain a misprint. Okay? So this kind of situation is that we need to find the probability that one of them contains a misprint, or no, none of them contains a
Because
misprint.
that's fewer than 2.
Okay, because that means we're talking fewer than 2. Yes? If it said 2 or fewer, we would include the 2 as well. Make sense? So, we need to find both of these two. So we've got 12, 0, 0.2 to the 0, 0.8 to the 12. Or actually, they're the other way around. We should at least put it under these, the right one. 12, 1, 0.2 to the 1, 0.8 to the 11, plus 12, 0.
Oh my gosh, my wrist is lying on my tongue. 0.2.
Okay, so they are our two values, and then this is our final answer. Okay? Are we happy that this is not too traumatic? Yes?
Yeah.
Okay, good. Let's use our counts in the normal way though. Okay, so that would be if you're having to show step by step. A bit tedious. But using the GDC. Okay. So if you're trying to find the probability of just one event happening, so where it's just equal to something. Okay, so I've tried to show the bits here. It automatically defaults to factorial because as soon as I get to here, it hits this page. So I was trying to show you in steps. So you want to go to probability, distributions, and binomial PDF. Okay, so the PDF is just where you're having one value. Binomial.
PDF?
So is it
First of
TD
all, I don't
or
have that.
CD or no?
It's D. Option D.
Doesn't have an option.
Scroll down, darling.
Okay. Binomial PDF.
Yeah?
Oh,
And then let me try it.
Okay, so when you enter that,
Okay.
then you're going to come up with this box here, and you literally do enter the information as they've asked it. So the number of trials, the probability of success, and which value you're looking for. So this is when you're looking for just one value. Okay? So, which example should we do? No, alright. So if we were looking at probability of something was equal to 3, we'd box put the x value to 3. Now, if you want a range like we had here, okay, so where fewer than 2, we knew it was less than 1, less than or equal to 1, okay? So we would use this one where it's binomial CDF, okay? So if you want to try and think of, I was trying to think C means cumulative. I actually don't know what it really stands for. Okay, but the CDF is where you're going with a range of numbers. Okay, so if I wanted less than 4, that means it's less than or equal to 3. Okay, so my value would be 3. Okay, so if it said less than 4, my value that we're interested in would be 3. Okay, if it says less than or equal to anything, that's obviously that value we're looking at. Does that make sense? Okay, and then you just chuck the values in the same. If your question's looking at greater than, okay, then you can look at the less than. So go do the less than option, and then subtract it from 1 because we always know probabilities add up to 1. All right. So let's do these examples using the count now. Okay. So X is binomially distributed with 6 trials, and the probability of success is 1/5 of each attempt. What's the probability of exactly 4 successes? So we're using our count in our screen. Oh, let me try to copy this. Boy. How do I get it out?
Yeah, here.
Alright, so if I was doing it on the calc, my number of trials is going to be what? 6. My probability of success is going to be 1/5. If you prefer it as a decimal, then it would be 0.2. And my x value for this one would be 4. Okay? What value do we get for that? 0.0.
1,
We need another digit.
3, 4. No, 4.
So remember, 3 sig big starts counting at the 1. Okay, part B, at least one success. Okay, at least one success. So that means the only one we're interested in is when x is 0. Does that make sense? So the probability when x is equal to 0. So if we were to do this thing again, is that hand up, Maddie? No. It says that hand up.
Oh, no.
So number of trials is still 6. Success is 1/5. This time our x value is 0. What value do we get for this?
0.262.
0.262. Now what are we going to do to actually answer the question? Because this has told us the probability that we don't get any successes. So
Minus
we're going to do 1, subtract that. Does that make sense?
Yeah. Minus
0.738.
Choose is. And then part C says 3 or fewer. Okay, so this is just a straightforward x is less than or equal to 3. So this time we're going to the CDF. Okay, so we need to go to the CDF. But our table, I believe, is the same. Okay, so secretly this says C. Our number of trials is still 6. It's still 1/5. And this is now 3.
It says lower bound and upper.
Oh, thank you. So it's completely a different screen. Oh, what the heck?
Same one, question.
I know. I thought I hit copy.
No, but my now has like just straight like that. Just straight like that.
All right. Okay. So our number of trials is
My mom is doing it.
Virgie.
Oh, what happened?
Thank you, Natasha.
Number 5, upper 5. What are these two right?
Well, you tell me. What's my lower bound? What's my lower bound?
3, 0.
No, I don't know.
0.
I said 3.
No, that's my upper bound. My lower bound is 0.
Oh. I had that one 14 already.
Yeah, whatever.
0.98.
0.983.
983.
Thank you. All right.